Here's my demonstration of the moment problem. The sum of all the horizontal forces must be equal to 0. The sum of all the vertical forces must be equal to 0. And the sum of the moments must be equal to 0. That is the key. So I'm going to sort of go through this with you and explain it to you. Like I'm typing here, these are the laws to remember. Sum of the horizontal forces equals 0, the sum of the vertical forces equals 0, and the sum of the moments equals 0. That's on page 44. So when you're working these problems, determinations of reactions in 3.9, you'll need to remember that. Of course, you need to read through all of that. But the problem asks you to, let me see, 3.9, write two equations of moments for the four forces shown in figure 3.15b, taking points C and D as the center of moments. The video I actually recorded earlier and my voice is later, so I'm trying to match this up because I couldn't do this at school. I could only do the video part at school. Anyway, so let's wait a minute till it catches up with me. Okay, here we go. So here I'm stating the problem again, 3.9a. We want you to write the two equations of moments for the four forces shown in figure 3.15b, taking points C and D as the centers of the moments. Remember, the sum of the moments has to equal 0. That's the key. It wasn't showing all my typing here. Okay, here we go. Now we're back. Now I've drawn the little diagram. You see that you have a force, a reaction force of 4.4 K going up, 7.6 K going up, 4 down, and 8 K down. What you need to remember is, I guess it follows my little mouse around, huh? The sum of the moments about C equals 0. Going back up to the laws, so every moment force around the center point C, all of them added up will have to equal 0. I'm just writing in the length there. From to the first force it was 6 feet, in the middle was 10 feet, and on the right side was 4 feet. So the next thing you got to know is are they positive or negative. So the 4K kips going down is going to be a positive moment because it's doing clockwise around C. The same for the 8 kips force, and then this force over here is going to be going the other way, so it's going to be a negative moment. So you got to figure that out first. Now we are simply going to write out our problem. And there we have it. We have C equals 4 kips times 6 feet plus 8 kips times 16 feet minus 7.6 kips times 20 feet. I'm showing you again, the direction of the moments. So if you do that math, you get 152 kips minus 152 kips equals 0. So there's your equation of the moments about C. The next one they want you to write 2. So the next one will be the sum of the moments about D. That has to equal 0 too. So you can see that. So you got to figure out your equation. I'm erasing my positives and negatives from before because that's not going to be true for this problem. And I'm going to redraw those pertaining to this problem. So about D, that 7.6 kip force is going to be a negative moment. The 4 kip force is going to also be a negative moment. And then the 4.4 force going up is going to be a positive moment. So now you got to write it out. D equals, and I want you to figure it out.